Okay, so this is graphing trigonometric functions part 2. And in the last video, we talked a lot about the differences between a periodic function and a sinusoidal function. And here in this video, we're going to go over the elements of a sinusoidal function. So what I've done here is I've actually just sketched one little segment of a sinusoidal function. So I didn't draw in all the other repetitions, but just one little, one section of the pattern, I guess you can call it. And we're going to go over some of the key terms of the key parts of this graph here. So if we want to start off with the maximum point. So notice that right over here, our graph reaches its peak, its maximum point. So we call it the maximum value, or the peak. So both those words can be used interchangeably. Now, here at the bottom, we can call this the minimum value, or the trough. So oftentimes, when we get into dealing with word problems, you might see the word trough. So don't let that confuse you. It just means the minimum value. Now, if we look at our periodic function and draw in a dashed line that cuts the graph in half horizontally, we actually call this line the equation of axes. And as we move along in this unit, just to keep it in short form, I will use the acronym EOA for equation of axes. Okay, now the distance, the vertical distance from the maximum value to the equation of axes is called the amplitude. And the amplitude is also the exact same as the horizontal distance from the equation of, the vertical distance from the equation of axes to the minimum value. So that as well is the amplitude. Now, I want you to make a very important distinction here. Amplitude can never be negative. It is always a positive value. The negative just tells you the direction in which you are measuring from the equation of axes. So, for instance, if we had an amplitude of -1, that would just mean that you're moving down 1 unit towards the -1 direction, okay? And if it was +1, you'd be measuring upwards towards the peak. The 1, the absolute value, is what tells you the distance from the max to the equation of axes, or the equation of axes to the minimum value. So always remember that amplitude is a positive value. Teachers will often try to trick their students with that, so just be mindful of that. Now, a couple of formulas that I want you to remember in terms of calculating the value of the equation of axes and the amplitude are as follows. Okay, so for equation of axes, we can determine the equation of that by taking the maximum value, adding it to the minimum value, and dividing by 2. And for amplitude, it's very similar, so try not to get the signs mixed up. It's equal to the maximum minus the minimum divided by 2. Okay? So it's a very important distinction to recall that with amplitude, we're subtracting, and with the equation of axes, we are adding. Okay? So in the next slide, we're actually going to work on an example in terms of sketching a sinusoidal function given certain information. Actually, before we go on to an actual example here, I forgot to mention another key property of the sinusoidal functions. So we've talked about the maximum, the minimum, the amplitude, the equation of axes, but we didn't talk about the period of the function. So in order to determine the period of any given sinusoidal function, a key property is that we pick a starting point in terms of our graph. So let's say that we want this to be our starting point of our sinusoidal function, and we want to determine what the period is. Well, in order to complete one period, you're going to go from your starting point. You must cut through a maximum as well as a minimum, and then return back to your original starting point. So in this case, as you can see, we started right on the equation of axes, which was 0. We went up to our maximum, which was 1, but in order to complete a period, we also have to cut through our minimum, so we keep going until we hit -1, but then we have to return back to our original starting point. So our period would actually be from 0 to 4 units. Okay, which represents one complete cycle. All right, so now we're going to move on to an example here. Okay, so in this example, it asks us to sketch 2 complete cycles, or periods, of a sinusoidal function that starts at the equation of axes and has a maximum of 9 and a minimum of -1. The period is 4 units. So the first thing that I would do is first of all figure out, well, what is my equation of axes equal to? So according to the formula, we know that our equation of axes is equal to the max plus the min divided by 2, which would be 9 plus -1 is -1 divided by 2, which gives me 9 minus 1 is 8. 8 divided by 2 is 4. So on my y-axis, where it's equal to 4, I'm going to draw in my equation of axes, which is supposed to be a dashed line. Now it tells me that my starting point is at the equation of axes. So I know that my starting point is going to be right over here. It also tells me that my period is equal to 4 units. So I know that to complete a period, I have to return back to my starting point. If I start on the equation of axes, I have to end at the equation of axes. So I know that at 4, I'm going to have another point on my equation of axes. Okay. Now I also know that I'm going to go through a max and a min, which means that I'm also going to have another equation of axes point right in the center of my 2 endpoints. So I'm going to have one right in the center here. And then in the first half, I'm going to have a maximum. But my amplitude, I don't know what my amplitude is. So I'm going to use a formula from the other page and calculate my amplitude. So amplitude is equal to max minus min divided by 2. So in this case, my max is 9, minus -1 is 10 divided by 2, which equals 5. So my maximum point has to be 5 units above my equation of axes. So 5 plus 4 is 9. And then same thing here. 4 minus 5 is going to be -1. And that would be my minimum. I would join my points, make sure it's a nice smooth curve, and that represents 1 period. But the question asked me to sketch 2 complete cycles. So I'm going to repeat the process. I know that every 4 units, I'm going to complete a period. So 4 plus 4 is 8, so that has to be another equation of axes point. Again, I know that right in the middle, I'm going to have another equation of axes. And in the first half, I'm going to have a maximum of 9. And then in the second half, a minimum of -1. Join my points, keep a nice smooth curve, and there you go. So just to recap, it's very important to understand the different elements of a periodic function, what they represent, and how to calculate them. I hope this tutorial helps, and in the next section, we're going to be reviewing how to actually graph sine and cos functions.